enorm.
Alright kids, welcome back to another flip video. Today we're going to work on a worksheet. Got about 26 problems you're going to do, and the titles are listed here of the kinds of problems we're going to do. Looking at polygons, looking at angles, solving some equations, also adding like terms. These are things you can do very easily, and we're going to go over the fundamentals. It'll be easy. A snap. Here we go. Here's problem number 1 for you. I'm not going to draw out the grid, but I want to show you need to find the coordinates for each of these dots. So you're going to have to take, if you can see this little red marker, and you're going to have to count how many steps it takes on the x-axis first to get to where the dot is, and then you're going to have to do the same thing and count the jumps going up, going up to the y-axis. Name the coordinates and you can solve this very easily. This is number 2. We're going to solve for p. Remember, we need to get the variable by itself, so let's get rid of the constant first. You've written this down. We're going to go ahead and add 7 to both sides and solve, and we'll have this is canceled out because 7 minus 7 plus 7, that equals 0, so p is left on this side, and we'll have our equal sign. 11 plus 7 is 18. That is our answer. Our next problem, we're going to solve for t. We have fractions, though, that we need to deal with, and we have a positive 1/2. We need to get rid of that, so we'll do the inverse, and that is minus 1/2. Since we do that on the left-hand side of the equation, we'll do that on the right also, minus 1/2. We know that this will cancel out over here, so all we'll have is t left. Now, this is a problem we need to deal with. We do not have common denominators. We need to make the 1/2 have a denominator of 6. So we're going to say 1/2, and we're going to multiply 3 to the top and the bottom. And when we do that, we will get 3 over 6. And as we have 3 over 6, we can go ahead and subtract 3 6 from 5 6. So it'll look like this: 5 6 minus 3 6, and we say equals, what's 5 minus 3? That is 2, and we have a 6 on the bottom. That's 2 over 6, which actually ends up being 1/3. So your answer, here it is, a little messy, sorry about that, but our answer is t equals 1/3. I will let you do number 4 by yourself. Here is number 5, and we have some decimals to deal with. X plus 5.4, or 5 4/10, equals 12.6. We're going to go ahead and do the inverse of positive 5.4 and subtract 5.4 from the left-hand side. We'll need to do the same thing on the right-hand side. And as we do this, pretty easy. X is left over here. Put our big equal sign. What is a 6 minus 4? Well, you'll have 2 left. Put our decimal point. What is 12 minus 5? And that is 7. So our answer is going to be x equals 7.2. Number 7 here, you guys can see this, is a triangle, and they want you to go ahead and classify this triangle. And you can see D, E, and F are the actual angles of this triangle. And I want you to notice that they've given you the measures of these angles in the triangle. And you can see one thing that is important, and is that they are all the same measure. Okay, you can start at D, and that is an angle of 60 degrees, and angle E, that is an angle of 60 degrees, and angle F, that is an angle of 60 degrees. They want you to classify this, and they've given you some names to look at. You have isosceles, equilateral, you've got isosceles right, and you have equilateral acute. So we want to take a look and see what is this type of triangle. Well, we can see that if I look at angle E, it is not larger than 90 degrees, and we know that an angle that is larger than 90 degrees, that is called obtuse. So that gets rid of C and, well, it gets rid of C because it's obtuse. But what is equilateral? Equilateral means that the sides are the same length. You can see that there's little hashed or cross marks in the sides, and that tells you that each side is exactly the same length. So it is an equilateral triangle, but which one is it? Is it going to be equilaterally obtuse? No, it's not. The only one that's left is equilateral acute. So your answer will be D. All right, guys, this next problem you need to take a look at is wanting you to find the missing angle. The missing angle is actually this angle up here, and I've marked it with this kind of a little mark at the top. And you're like, well, how can I figure this out? Well, this is the way that you do it. Any triangle, when you add up all of the internal angles, they always equal 180 degrees. Being that said, we can go ahead and use some addition and subtraction to figure out what is the missing angle. Let's check it out. Since we know that all the angles together equal 180 degrees, we can go ahead and add 47 plus 49 to figure out how much those two angles equal. And when we do that, we can see that it equals 96. Now, I'll let you take a moment to think about what would you do next. If you thought about taking 180 and subtracting 96, bravo. We do that, and we will go ahead and say we need to borrow from here, make that a 7, make that a 10. 10 minus 6 is 4, okay? And then we have a 17 minus 9, and we know that that's going to be an 8. We have 84, okay? Now all we have to do is take this 84, and we can add it up to this, and we will get a 180. Now we know that when we do this, we can figure out what is left. This 84 actually goes up into this answer here. So N equals 84 degrees. That is our missing angle. That's a funny degree mark. Here you go. Bang. All right. When you're looking at the angle of measure S, let's take into account what we just learned from the previous triangle. Any triangle, when you add the internal angles, equals 180 degrees. Remember, if you have two angles, you can find the third. So you have 34 degrees as angle T, but what about angle R? Yesterday in class, we talked about that little square, meaning that that is actually 90 degrees. Knowing that, use that information to find out what angle S is. Okay, in this problem, I skipped down to number 14. The rest of those I think you could figure out on your own. But let's take a look at these terms here. We have a minus 4x plus y plus x plus, minus 2 minus 6. This is the part where you're going to be adding like terms. Remember, a like term is actually what it says, things that are exactly alike. So you can see here we have a 4x and we have a plain x here. Those are like terms, so we can actually add those together. So you have a minus 4x plus an x. We actually turn that into a minus 3x, okay? Now we can say plus y. Do we have any other y's in this math terms here? No, we do not. So we say plus y, leave it as such. And then we can say minus 2 minus 6 more, which actually ends up being minus 8. This is your answer. You are done. Just last little bit here, and you're going to be set free to finish this Worksheet on your own, take a look at this as we go and add like terms. If we have a j plus j, how many j's do we have? We actually have 2j, so it becomes 2j. Okay, it shows that. What about an xy plus y? You do have a y on both sides, but actually this xy is the term itself. So xy is not the same as y, so you cannot add this together. You cannot. And the last one right here is 4st plus another st. So if you have 4 st's already, you add one more, you're actually going to have 5st. Very good. You're on your own. This will be due on Monday. Have a good weekend.